Mic check 1 2. Mic check 1 2. Alright, we're good. We'll get started in about 5 minutes. All right. How's everybody feeling today? All right, welcome back, everybody, to week 3 of VGDev. Today, we have a couple of announcements for you, a Unity workshop, and then we do not have racquetball because, unfortunately, the CRC made a bit of a scheduling snafu, and so we can't do that, but we're going to try and throw together something after. If people want to go play in the Burger Bowl or play some games here, we'll get that situated at the end. Before the workshop, we have a couple of announcements for y'all. First things first, is there anybody here who has not downloaded all of the assets, so the Unity version and the GitHub repository for the workshop? Okay. If you haven't, please go onto Discord on your computer, and there's a setup doc there with all the files. Hopefully, you should have enough time going through the announcements, and I'll wait as well to get it downloaded. If not, because it does take a bit, find someone to watch along with, and the workshop will also be posted. Unfortunately, we aren't going to have time to wait for everyone's downloads to finish, because they can take up to 20 minutes. So, yeah, if you don't have it downloaded, get on that now. Attendance. I fixed the QR code this week, so this is the correct one. So please scan attendance. This is how the COC knows that we are alive. And also, the more people that do attendance, the more snacks we get. So yeah. Give everyone a few minutes to fill that out. All right, is there anybody who has not scanned the attendance form yet? 5, 4, 3, 2, 1. All right, first off, I want to give a congratulations to some of our teams who won a couple of awards at Global Game Jam this past weekend. We had 2 teams made of VGDev members that won awards. So Grid and Gas won Best Use of Theme. That was by Vittorio, Jessica, Tristan, Will, and Carlos H. And Overboard won Best Design. That was by Vu, Carlos S., Jasmine, and Chris. So congrats to them. Congrats to everyone who participated in Global Game Jam this weekend. Some really great stuff that was happening over there. We also have a cool event that's happening tomorrow, an experimental game showcase. So local game developer Eric has pulled together a bunch of artists and developers, literally from all over the world, to show off a bunch of cool and experimental games. That will be at the Cabbagetown Arts Center from 10 a.m. to 11 p.m. tomorrow. Obviously, you do not have to be there the whole time. We did set up a carpool sheet. So if you are interested in going, you can go ahead and check that and see if somebody has any spots available. You can also MARTA to a nearby station. You can check our previous announcement on Discord for more information about the event. All right. Tablet and headset rentals. We have 3 Wacom One drawing tablets that are available to rent. We've had those for a little bit now, so if you are ever interested, send me a DM on Discord, or if you know that you're interested right now, you can come talk to me after the meeting, and I can get you checked out. Yeah, depending on how in demands they are, the time you're allowed to check them out for might vary, but I'm hoping, to give you at least 2 or 3 weeks if you want to use it for working on a game or for something else. And also, something really exciting was we finally got 2 MetaQuest 2 headsets. So we aren't working on a VR game right now, but this is really big if we ever do have another VR game that's pitched, because I know not having a headset to work on has been a pretty high barrier to entry. We are still getting those configured and set up. They literally just came in a few days ago. So they're not quite ready to rent out yet, but we will make an announcement at a meeting and on Discord when that is the case. So look forward to that. Anyways, it's time to... No, we're not spinning that wheel. It's time for the Unity workshop. So I'm going to go ahead. Again, hopefully you have everything downloaded. If you don't have everything downloaded, find someone to follow along with, and you can watch this video after the fact. Also in the room, we have a couple of lovely experienced VGDev members. If you are, we're going to be helping you guys out. Could you guys raise your hands so people know who you are? Awesome, awesome. So if you guys have any troubles during the workshop, feel free to raise your hand. One of them will come around and help you out. And then, if needed, will flag me down to slow down or explain something as well. I'm going to try and go at a reasonable pace, slow enough so that way I can keep everyone engaged, but fast enough because we do have quite a bit of stuff to get through, and I don't want to keep you here for hours on end, even though I really could. So, let's go ahead and get started. So, the first thing you're going to want to do is you're going to want to go ahead and open up the Unity Hub. So you'll see on my screen I have a big old, also if anyone ever wants me to zoom in, because I keep my stuff on my computer pretty small, please let me know. I'll do my best, especially on VS Code and stuff. So there we go, there's the Unity Hub. I have a big list of projects. You will probably see nothing. But what you're going to want to do is you're going to want to hit this open button here. There's a little drop down, and you'll see add project from disk. So you're going to go ahead and click on that. Then that should bring up a Finder window somewhere on your computer. And then you're going to need to go locate that GitHub repository wherever you did it. So that default installation is going to be in Downloads. Sorry, my bad. Documents, GitHub, VGDev Unity tutorial. If you installed it somewhere else, like on your desktop, or if you have a specific folder, go ahead and follow that path. Make sure you select the base folder. Don't click into this. You'll see a whole bunch of Unity stuff here. So if you see, like .git, idea, VS Code, assets, library, you've gone too far, go one level back. Just click on the folder and then hit add project. And once you've done that, you'll see it pop up in your projects list here. So you can see VGDev Unity tutorial, the time it was modified, and the Unity version. So I'll give everyone a couple more seconds to get that situated. And then when you're done, go ahead and raise your hand when you've got the project all linked up. No, John, we're doing this the other way. Okay, that's a good idea. Thumbs up if you've got it installed. If you're still working, big thumbs up so I can see them. If you're still working, go ahead and just raise your hand and someone will help you. Yeah.
So if we haven't done any of this, we have to go into GitHub and download files, and that's what we're on.
Yes, there's on our Discord, there's the link for all the setup instructions. What I recommend for now is just following along, and then this video will be posted, so feel free to go through it all after. But yeah, we just, like I said, I wish we had time to wait, but like I remember we ran this at HackGT once, and it literally took like 40 minutes for some people, so that's how it is. But I still think it's pretty valuable to follow along, even if you aren't doing the programming yourself, or I certainly hope so. So anyways, anybody else who does not have the project appearing in their Unity hub? All right. Awesome. So go ahead and double click on the project to open it. And clicking on this will boot up Unity. It's doing it on my other screen, so let me go ahead and drag the window over. Something important to note is that you will always be launching Unity through the Unity hub. So you might see like a shortcut link to a Unity editor version on your desktop somewhere, but you're always going to launch the project through the Unity hub. And once you launch it, you should see a screen that looks something like this. So everyone go ahead and give me a thumbs up when you've gotten to this screen. All right, anybody else still waiting? Awesome. Okay, so this is Unity, and your first thought is probably, holy crap, that's a lot of stuff. Because yes, it's a lot of stuff. But I'm going to go ahead and break it down for you. So you'll see there's a couple of different components to the Unity editor. So the first one up here is going to be your taskbar. You'll probably recognize this from a lot of other programs, but you'll have all sorts of options here that do all sorts of stuff. You don't need to really worry about that for now. In the center of your screen is going to be your view. So this is where you can see your scenes. Scenes are kind of like levels where you can put stuff together. They're kind of like isolated little parts of the game. You can transition between scenes. You can load stuff in, do all sorts of cool stuff. We're going to go ahead and get into a scene in a second after we're done with the hierarchy here. You can see on the top of this main window, we also have some other buttons. So by default, these will be game. So you can see when you have a camera set up in your scene, this will show what the camera sees. And when you click these buttons up here up top will let you run the game in the editor, so you don't have to make a full build or anything to play test your game. you can just click the play button and run your game demo. And then I have the animator tab open. We don't need to worry about that right now. On the left side is what's called the hierarchy. This shows all of the different objects in the scene. So right now we're in like the default scene, so all we have is a main camera and a light. But in a minute we're going to go ahead and open up a scene that we have already created for you guys, and you'll see there's many objects in there. On the right side of the screen we have the inspector. So when you click on an object, you will see stuff appear in this panel. So these different things that you see here are called components. So you can see that this camera has a transform component, a camera component, and an audio listener component. Unity uses what's called an ECS, or an entity component system, which basically means that you can put multiple different kinds of behaviors onto one object. So you could write different scripts, you could add different things like colliders, physics simulation, materials, cameras, images, UI elements. So there's all these different pieces that you can put onto the same object. So if you hear me refer to things as components, I'm talking about these things that appear here. You can actually see there's an add component button at the bottom. And if you scroll through this, you can see, again, there's all different kinds of different components in different tabs. The last main piece is this bottom bar here, which has two sections. The first one is your project folder directory. So this will show you all of the different assets in your project. So you can see we've gone ahead and created a couple of folders for you here. We recommend using folders to organize different stuff in your project, just as you would any other sort of files in your computer. So you can see here we have a scenes folder where we have our scenes. We have a scripts folder, which is where we write all of our code. We have some models that we imported. We also have a folder called prefabs that I'm going to explain a bit later. And in general, the more stuff your project has, the more of these kinds of folders you're going to have. So it's pretty common to have like a folder for sprites, images, audio, materials, shaders. Again, kind of the bigger your project is, the more organized you're going to need to be. The other option that you're going to see on this bottom bar here is the console. So this will where you'll be able to print errors and text. So when we get around to writing scripts, if we ever print stuff to the console, you'll be able to see it on this side over here. Awesome. Is there anyone who has any questions about the Unity layout so far? Cool, cool. So as you can see, we're currently in this untitled scene, and we don't have anything. But luckily, we've set up a scene for you guys. So if you go ahead and click on Scenes, and then we have a scene, very creatively named Scene. Go ahead and double-click on that, and you'll see a new scene will now open up. So everyone go ahead and do that. And now you can see we have some stuff in our hierarchy. So again, we have a camera that we have this player script attached to. We have a skeleton enemy that we've imported here, and we have a level. This also shows you that you can nest game objects together in the hierarchy. So this level is like a parent object for all of these different backgrounds. So if I go ahead and disable this level object, you can see all of the background goes away. But I could also do that individually. Like I could disable the floor here and all sorts of other stuff. Awesome. So now we have a scene loaded. We also have a couple of different tools. So if you've ever used any sort of 3D software, these tools will seem familiar to you. So we have the move tool. So this will give you 3 axes. So you can move objects in the X, Y, and Z axes. You can also see here this is affecting the object's transform. You can also manually type in values. So if I want this skeleton to be at x equals 5, I can go ahead and type that in over here as well, in addition to using the tool. There's also hotkeys for all of these tools. So the hotkey for the move tool is W. So if I have some other tool selected and I want to switch back to the move tool, I can press W on my keyboard, and you can see here the move tool selects. Then we have the rotate tool, which will rotate objects. So if I select my skeleton here and then click this or click E to use the rotate tool, I can rotate him around on different axes like this. It's not look very pleasant, but you know, to each their own. And once again, you can also manipulate rotations on the object's transform properties over here. So just like that. And then the final important tool is the scale tool. The hotkey for that one is R. This allows you to scale objects. You can either scale everything all at once, just like that, or you can scale specific axes. So if you wanted a really wide skeleton, you could have a really wide skeleton. And once again, you can manipulate that on the transform component of an object as well. Something important to note is that a transform is the only component that all objects will have. So regardless of what it is, it will always have a transform component. And something else to note is that transforms can't exist without game objects. So we won't be getting into this today, but sometimes there are instances where you might want just to transform, and you kind of have to create an empty game object to go along with it. That's just a bit of a Unity quirk. But let's actually do something. I just realized I never told you guys what game we're going to be making. We're going to be making a little first-person shooter where you're going to shoot some bouncy red orbs at waves of skeletons. So let's go ahead and make one of those. So there are two ways to make game objects in Unity. The first one is to right-click in the hierarchy, and you'll see a list of game objects you can create. So you can go 3D object, and we're going to go ahead and make a sphere. Or you could do it from the top bar as well. So you could click game object, 3D object, sphere, and that will spawn in a sphere as well. But I only want one sphere, so I'm going to go ahead and delete that. And then I'm going to take the sphere that I have here and move it up so it's not intersecting the ground. All right. And then everyone go ahead and give me a thumbs up once you've gotten in a sphere. And if you have any questions, feel free to ask as well. Yes, good point. Mouse controls. So you can use your scroll wheel or pinching on your trackpad to zoom in and out. Right click will move the camera around. You can also middle click. So right click will rotate the camera around, and then middle click will pan the camera. You can also use Alt and right click to zoom, Alt left click to pan. So that's how you move the camera around. I think you might be able to use control. Okay. Yeah, so you can use Alt as well if you don't have a middle mouse button. All right, everyone good. Awesome. So we have a sphere here. We're going to want to do a couple of things with it. So first, we're going to want to go ahead and change its material. So materials are how objects look. You can do all sorts of fancy stuff, but for now, we have a material made for you already. So if you scroll in here, you see we have a material called plain orb, which is just red. In order to apply that material, go ahead and use the Project Explorer to go ahead and navigate to it on the bottom. And then you can simply drag it and drop it onto the object, and you'll see that this orb now has a red material on it. Materials, we also have what are called physics materials. So regular materials are for the way an object looks. Physics materials are for the way an object behaves in the physics system. So this sphere currently has no physics material on it. You can see on its collider here, which is how things actually have volumes to interact with physics. You can see that we have no material on it, which means it'll just behave like normal. But we went ahead and made this bouncy material. So you can see here, we changed the static friction to 0 and the bounciness to 1. So that way these orbs are going to bounce. So once again, we can go ahead and take the material. You can also assign materials in the inspector to specific components. So in this case, we could drop it on the object, but you could also go ahead and go over here and drag it onto this non-physics material selection, and that will set the material as well. So awesome, we have a bouncy ball, right? So we can go ahead and click play. Actually, let me see where the main camera is. Yeah. All right, we can go ahead and click play. Right, and oh, I also forgot to mention, we set up this script so that when you play, you'll be able to rotate around with your mouse as well. So we hit play, and there's our ball, and wait a second, it's not doing anything, right? So you might be wondering what's up with that. And the reason is because even though we gave it a physics material, we did not give it something called a rigid body. So a rigid body is required for any object that is non-static, or you want to apply physics movement to. Right, so even though this has a collider, it's just going to sit there. So we can go ahead and go to the right here and click Add Component and add a rigid body component. Make sure you select rigid body and not rigid body 2D, as the name kind of implies. That is for a 2D rigid body. Unity's 2D and 3D physics systems are two completely different things. which might sound a little weird, but they are implementations of two totally different systems. This happens a lot, especially in 2D. I cannot tell you how many times in 2D physics I've tried to use the 3D physics raycast and spent hours debugging to go, oh my god, I tried using the 3D physics raycast. So just always make sure that if you're working with 3D physics, you use regular components, and if you're working with 2D physics, you use 2D physics components. So I'm going to go ahead and add a rigid body to this object. There's all sorts of different properties in here. We can set the mass, the drag, angular drag, center of mass, whether or not it uses gravity, and then something called kinematic. The two important ones that we're going to talk about right now are gravity and kinematic. Gravity does exactly what you expect it to. If that box is checked, then this object is going to be affected by gravity, which is good. That's what we want. I'm just going to go ahead and move it a little up as well. Kinematic means that the rigid body won't move on its own. So even though I have used gravity enabled, if I hit play or I ran into the object, nothing would happen. Kinematic means that we are going to control it exclusively through code. So this could be really useful. For example, if we had like a moving platform that we want to move back and forth between 2 points, we want to control that with code. We don't want the player running in to knock the moving platform off its path. But for now, we're going to go ahead and uncheck that. And now if we hit play, it didn't bounce. Awesome. Very cool. Let me check the scene view. There we go. Now it is. It's just because I wasn't looking at it. That's the other important thing to note. So even though when you hit play, it defaults to game view, you can still go to scene view, manipulate your game during playing it, right? So I can go ahead and use the move tool to drag this ball up and drop it, and you can see now it's going to go ahead and bounce, just like that. Something important to note is that any changes you make while in play mode will not be saved. For example, if I take this ball here and I go ahead and use the scale tool, so I'm going to hit R, and I make the ball really big, right? So it has a scale now of like 5 point something, and I stop playing, you can see the ball scale has gone back to 1. So making changes during play mode can be a great way to test things, manipulate values, manually reset things without having to restart the scene. But it's important to note those changes aren't saved. So if you move an object around, you might want to like copy values to your clipboard or remember where stuff is. So make sure that when you're editing, you are not in play mode. Something else to note is to make sure to save your changes. Unity does not auto-save, which means if Unity crashes, which it does tend to occasionally, or your computer dies, or XYZ, your changes won't be saved. So you can see we have unsaved changes by this little star icon next to the scene name. You can always save by just going Control S or Command S if you are on Mac. And you'll see that little star went away, which means we've saved our scene. So we are all good to go. All right. Anybody have any questions?
I wanted to ask, is there a way to adjust sort of the starting camera position when you move into different?
Oh, yes. So we're going to implement player control in a little bit, but for example, if you wanted to move the player around on the scene, you can move it around like this. The player looking at the ground at the start is just how the script is, but we're going to fix that when we get into scripting in a couple of minutes here. All right, so what if we want more bouncing balls? Well, the easy thing to do might be Control D, right? And that works as expected. You can also Control C, Control V for copy paste. Control D is duplicate, which does all that, right? So let's say we want 3. Awesome, now we've got 3 red bouncy balls. But what if we decide that actually, we want these to be bullets in a game, and they're kind of a little stupidly oversized, right? And we want to make some sort of change to that. We know we can do that using the scale tool, right? So I can click R and do that, and then great, that only did it for one of them. Now I have to do it for every single object in my scene. There's only 3 of these, so that might not be that bad. But imagine, for example, we wanted to change the scale of these trees, of which we have dozens, right? That could become really annoying really fast. So luckily, Unity has a solution for this, and it's called prefabs. Prefab is short for prefabricated object, but essentially what it allows you to do is it allows you to store an object in your project and make copies of it whenever you want. and any changes you make to the base will be made to the whole object. So I'm going to go ahead and delete these other two spheres here. All right, so now we have this one. To make something a prefab in Unity, all you do is you take the game object in the hierarchy and drag it down into the inspector. So I can go ahead and do that, and you'll see I get this new object called sphere.prefab. I'm going to go ahead and move that into the prefabs folder because we want to make sure we keep ourselves organized. And now I can go ahead and double click on this, and now I'm editing the prefab. Actually, before I do that, just to show you, you can drag prefabs from the project into the scene to make multiple copies of them. So I can go ahead and do this, right? And now I have multiple spheres in my scene, and they're all the same size, and that was a lot easier than copying and pasting everything. The other important thing about prefabs is the fact that any changes you make to them will be made to every instance of that prefab. So if I go here and I decide I want to bring the scale back up to 2, for example, so I'll go ahead and click R, and I'll scale this thing up, or 1.6. Again, we're going to go ahead and make sure we save the prefab and go back into the scene, and look at that. Now all of our balls have grown larger in scale. But we're going to go ahead and shrink this down. I like something like maybe 0.1. Also, just a little tip, if you're editing scale values, you can see there's a little icon here, a little chain. You can swap, so if the chain has the link in the middle, that means that they're going to be the same, and if it doesn't, that means they won't. But if I enable this link, that means I only have to change one value, and all the other ones are going to scale accordingly. So we'll go ahead and save that. And there we go. All right. Anybody have any questions? All right, cool. So it's time to write some code. So we have a couple of scripts for you guys. So scripts are what Unity calls its code snippets. Yeah, so we've made a couple for you. If you wanted to make a new one, you could right-click and hit Create C# script. We're going to do that in a little bit. But first, I want to explain to you some important things. So Unity is written in C#, which is Microsoft's version of Java, basically, is how I like to explain it to people. So if you've ever worked with Java, this should be pretty easy. If not, it's not the easiest language in the world, but it's not the hardest. And luckily, the Unity documentation is pretty good online with helping you with stuff as well. So you can open scripts by double-clicking on them, and that will open Visual Studio Code if that's your default development environment. You can choose to open it in something else as well, but I recommend VS Code. All right, so you can see we've written a couple of lines of code for you guys here. The most important thing to know, though, is that Unity has a bunch of special functions, right? So in Java, the special function you might know is the main function. There are equivalents also in like C and Python and all sorts of other languages, right? And the main function is always going to be where your code starts execution. Unity is a game, so it doesn't have an overall main function. But there are special functions you can write on objects that are called at special times. So for example, this start function here, start is going to be called before the first frame of your game is run. So if you have any configuration or setup that you want to do on your game objects, you write that code under the start function. Then the other important function to know about is the update function. Update is called every single frame of your game. So this is where you want to do things like handle input, move characters around, anything that needs to happen in real time as your game occurs. There are lots of other special functions as well for stuff like collisions, animation, and we're going to cover a couple of those later today. But for now, these are the two most important ones to know, are going to be start and update. So just to demonstrate those, I can go ahead and write some quick print statements. So in start, I could write print start. And in update, I could write print update. Go ahead and save that. And then those are my player script, which is in the scene. So if I click start to run the game and go to the console, you can see it printed start and it's printing update. You might not see this. You will probably see this, a console getting spammed with updates. Unity console has this nice thing called collapse mode where you can click on it and it will make anytime the same message is printed from the same object all collapse into one. So you can just see that I'm getting 10,000 updates in one line instead of having 10,000 lines of single updates. Cool. All right, anybody have any questions on start and update? All right, cool. So now we're going to go ahead and start working with input, right? So input is kind of the key to every game. If you can't input anything, it's not really a game. It's just like, an animation. So arguably, learning how to do input is the most important step for any game. So Unity has a bunch of built-in functions for input. You might also hear people sometimes talk about something called the new input system versus the old input system. They're just different ways of handling input. We're going to use the old input system here because it's a little bit simpler, but many of the games that you guys are working on will probably use the newer input system, so you can speak to your team leads for more information about that, or look at it online. So let's explain what we're doing here first in the code we've already written. So we have this function called hide and lock cursor. This basically puts the mouse in the center of the screen and makes the cursor invisible, which we want because this is a 3D game, right? We want our mouse movements to turn the camera. We don't want the mouse moving across the screen. So that's what that function does. Then we have this mouse move function here, which is reading mouse input. So this input.getAxis function here is going to go ahead and print out how much your mouse has moved in the X direction and how much it's moved in the Y direction. In fact, to see that, it's going to be a little easier if I go ahead and print those values out. So print. Your print functions don't have to have strings in them, or string literals, should I say. You can print all sorts of stuff. So that. Compile. And if I go ahead and click play, you'll see it's printing 0, and then I can go ahead and you'll see the different numbers pop up as I move my mouse around. Just like that. I'll go ahead and clear those values from the console. And let's see what this code here is actually doing. So our rotation X is going to be this transform.local Euler angles.y essentially is because when we move the mouse side to side, that's actually on the y-axis in world space. We're going to go ahead and take that and add it to our input times our sensitivity. So if you think the camera is going too fast, we can change the sensitivity. And the cool thing about Unity is that public variables are editable in the inspector. So if I click on this player object here on the main camera, you can see we have sensitivity X and sensitivity Y at 2, but let's say I think the X movement is too fast. I could lower this to 1, for example, and then it will take moving the mouse twice as far to rotate left and right. And again, the same thing applies here as for game objects. You have to make sure that if you edit these values during play mode, they won't be saved. All right, cool. And then we can see our rotation Y. We're going to do a similar sort of thing here. And then we're just going to go ahead and set our transform. So all this script is doing is it's looking at your mouse input and setting the camera position accordingly. But this is a shooting game. We're going to want something to shoot. And the good news is we've already gone ahead and made ourselves a bullet. So something else cool about prefabs is that you can make references to them in your Unity scripts. So if I go ahead here, right, and I want a bullet object, so let's go ahead and add it. I'm going to go up here, and I'm going to put type public game object. So a game object is the type, that's what everything in Unity is. Anything you see in the scene is a game object. So if you want to reference something actually in your scene, you're going to use that bullet game object. And then you can use a function to spawn in game object, and that function is called enchant. So we could go ahead and write our code directly in the update function, right? We could write every frame. We could say if mouse click spawn bullet. But that's not really great coding practice. Right? Better coding practice is to segment different different functions into, well, different functions. So let's make a new function for getting the mouse input. So we're going to go ahead and call that one. Let's call that function mouse input. Public void. And let's say we want to spawn a bullet every time we left click, right? So just like in a shooting game, we're going to want to click to shoot. So we can check our inputs. The left mouse button is mouse button 0. So if inputs.get mouse button 0, and then we're going to go ahead and add some curly braces, and then we're going to do instantiate. We're going to instantiate. Instantiate takes a couple of arguments, so we can go ahead and instantiate bullet, and then it's going to take a position and a rotation argument. So we want to spawn it right at the camera, so we can use transform.position to get the position of the current game object, and then quaternion.identity, and that will get the current rotation. Also, if you're wondering what a quaternion is, it is a 4-dimensional vector for rotations. You do not need to worry about them or how they work exactly because they are admittedly very complicated. But all you need to know is that it's a better representation of rotations than just the standard rotational axes. So cool, we now have a script that every single frame is going to check if we have mouse input, and if so, is going to go ahead and spawn a bullet. So we can go ahead and save. Go back to Unity. And then it's important to note, we have to drag the reference to our prefab in here. So if we go ahead and go back to our prefabs folder, we can click it here, and then drag it over. You can also search for stuff directly in the project inspector here. So if you click on this little bullseye icon here, you can have a game object selection where you can select objects both in your scene and also from your assets folder. So since we're spawning in bullets, we don't really need them in the scene anymore. So I'm going to go ahead and delete all of these ones that we made. Save. And run the scene. All right. Great. Awesome. We've now spawned approximately several hundred balls. Great. So the reason for this is because we don't have any sort of cooldown time on our spawn function, right? It's checking every single frame for mouse input. And because this is not a computationally intensive simulation right now, I'm probably spawning in about 200 of these rigid bodies, these little bullets, every single frame, which is not terribly useful and will crash my computer pretty quickly. So I'm going to go ahead and stop that. Is everyone following up to this point? Does anybody have any questions? Yeah. Okay. John will come and help you out. So did you make the prefab? Okay. If you click on it, here and click the bullseye, you should be able to see it, and you can search for it in your assets. If it's not showing up, you might have also made the variable private in the script. You want to make it public so it shows up in the inspector. All right, cool. So let's go ahead and make it so we have a limited rate at which we can fire the bullets. So this is going to be a parameter that we're probably going to want to control. So I'm going to add a new variable for it. Let's call it public float fire rate equals 0.2f. All right, cool. And now we basically want to add a check where we want to see how long it's been since the last fire time, right? So we're going to go on ahead and store that in the variable 2. So I'm going to make that a private variable since it's something we just want the script to set. We don't want us to have any mess with it in the inspector at all. We're going to call that private float last fire time. And save that. That underscore on front is just kind of a C# convention for how private variables are named. You don't have to have that, but generally speaking, it's good coding practice if you do. All right. So now on our mount input function, we can go ahead and check. Right. So every time we fire, right, we want to set the last fire time. Right. The last fire time is the current time, and you can get to the current time with time.time. So that will print the current time. And then basically you want to add a check where we're only going to call this instantiation code if enough time has passed. So we can add a check for that here. If time.time minus last fire time greater than or equal to fire rate. So what is this block of code doing? That's saying, hey, let's check the time it is now and subtract the time it was when we last fired, right? So if the time is currently, 1, and our last fire time was at 0.5, 1 minus 0.5 is 0.5, right? So it's been 0.5 seconds since the last time we fired. And then we're going to check, is that greater than or equal to our fire rate? And if so, that means it's been long enough that we can fire again. So I'm going to go ahead and take this code and paste it in here. There we go. Let that compile again. Cool. And now if we hit play, you can see that, I can run balls pretty often. If I go ahead and lower my fire rate, so for example, let me set this to 1, right, and I hold down, I can only spawn a ball every second. So there we go. We now have a fire rate implemented. The other problem we have right now is that we're just kind of spawning the balls right at our position and then dropping them down, right? We want to give them some sort of momentum just like an actual bullet would have. And that's where that rigid body that we added on earlier is going to come into play. So I'm going to go ahead and go back to our script here. We can access components from game objects with the .getComponent function. So, for example, if I had some game object, right, I could do bullet.getComponent rigid body. And I want to save a reference to that. Right. But this actually isn't what we want. This is something pretty subtle here. So this rigid body is going to be a reference to the one on the prefab, which means that if we change any values here, it's going to change for the prefab. It will change for every bullet in the scene. So if, for example, we set the velocity to 1, then every bullet's velocity will be set to 1, right? And we don't want that. We want each bullet to operate independently of the others once it's been spawned. So instead of getting it from our prefab, we can actually call getComponent on the game object that we instantiated, right? So I can call .getComponent, and I can save the reference here. Okay, cool. And then we want the bullets to shoot forward, so we can do r.velocity equals vector3 dot forward times 10. Cool. So if we save that and play the scene, we can see that our bullets now shoot forward. But we want them to not just shoot, right? They're shooting forward in the direction of the world. but we don't want that. We want them to shoot forward in the direction of the camera. So in order to do that, we can also manipulate that velocity vector. So I'm going to go ahead and click the scene, go back to our script here, and you see we have this line up here that I commented out earlier. If you don't have this line, you can also type it in yourself. And that is quaternion camera rotation equals quaternion.Euler transform.Euler angle. Again, this is a bunch of like weird vector rotational math. The important thing for you to know is this translates the angle that the player is currently looking at into a quaternion. And the reason that's important is because you can multiply vectors by quaternions in order to rotate them the rotation of the quaternion. If this was just a rotation vector, we'd have to do like all sorts of like sine, cosine garbage, but we don't have to do any of that. Instead, we can just set the velocity to camera rotation times vector 3.forward times 10. Go ahead and save. All right. Cool. And we've done it. We can now fire bullets in whatever direction we're looking at every 0.2 seconds. Awesome. All right. Is there anybody who's not at that point yet and needs some more help? Yes, absolutely. All right. Anybody else need some more help? If we have any helpers in the audience, we have one more person. Two more people. Veterans in the corner. If you have people who need help, please help them. Thank you. All right. I know some people are still getting some help, but we do have a lot still to get through. So if you go ahead and click play on the scene, you might notice that we have this skeleton guy who just kind of walks forward aimlessly off into the sunset. And that doesn't make for a very good game. It would be a lot better if he was trying to attack us. So let's go ahead and get that set up. So in order to do that, we're going to want to make a new script. So if we go into the scripts folder, we can go ahead and right-click and hit Create C# script. And we're going to name this Enemy. All right. So now we have a new enemy script, and we want to go ahead and put it on the skeletons here. So let's go ahead and put the enemy script on the skeleton. And then we can open the script by either double-clicking it in the console, or if you have something selected that has the script on it, you can click the 3 dots and hit Edit Script in order to pop the script open in VS Code. You could also access it from the VS Code hierarchy over here. So there we go. We have our 2 functions, start and update again. By default, Unity will put these on any new script you generate, but you don't always need them. So, for example, the skeleton that we've made here, him always walking forward is actually handled by animations. So we don't need this update function. Right? But we are going to need this start function. So we're going to want the skeleton to look towards the player, because if he looks towards the player, then he's going to move towards them. So we already have some code for this, so we can call it. We can call helper.lookTowards. It's transform vector 3.0. What this does is now whenever the skeleton spawns in, the first thing that it's going to do is it's going to look towards the center of the map. So in order to demonstrate this a little better, I'm going to move him farther away because right now he's pretty close. So I'll grab our skeleton enemy and send him off over there. Cool. So now the skeleton walks towards me. Yay. But we're going to want to be able to defend ourselves somehow. Actually, before I do that, is everybody at this point, or are people still working? I'll give everyone a few minutes just to catch up here. Yep, yeah. We'll have the Twitch video up hopefully by tomorrow at the latest. So, you can also see we've also ran this workshop last fall as well, the same one. So that's also available. If you go to our website and look at our past meeting recordings, the playlist for last semester, that one is already up, and I can send it in the Discord as well. All right. Yep. So all we have the enemy script doing right now is just looking towards the center of the world. All right. Is there anybody else who's still working to get to this point? All right, awesome. So we want the bullets to kill the skeleton when they get hit. So in order to do that, we're going to write a script on the bullets. It's a pretty simple script. So let's go to bullet. I think it's called sphere. So go ahead and do that and double click to open up the prefab. And I'm going to show you how to make scripts the other way now. So once you've double clicked and opened the prefab, you can go to the bottom of the inspector on the right side, and you'll see there'll be an add component button here. You can click that and then click new script. And let's name this one bullet. Create and add. The other thing to note is that when you create scripts using the inspector, by default, they're going to show up at the root of your project directory. So like you can see here, the bullet didn't show up in the scripts folder. It just showed up kind of at the base here. So whenever you do that, just make sure you put scripts in their right folder. That's, I think, the easiest way for things to get messy is sometimes you'll create a bunch of scripts and they'll all end up in the base folder and you won't notice it, and then your files become really disorganized and nobody likes that. All right, cool. We aren't actually going to use this bullet script quite yet. We're going to go back to the enemy script. But the fact that the bullet now has the script on it is really important because now we can go ahead and check for that. So, opening up our enemy script again. We're going to add a new function here, and we're going to call it onCollisionEnter. This must be spelled exactly this way because this is one of those special Unity functions I was talking about earlier. This function will be called whenever one rigid body hits another rigid body. So in this case, if we have an object that hits our skeleton, right, we're going to want to check and see, hey, is that thing a bullet? And if so, we're going to want to, destroy the skeleton. So we can go ahead and check the bullet as such. So let's try and get the bullet component. So bullet, bullet B equals collision.nameObject.get component. And then if this is defined, then we can just add a null check. If B is not null, because if there is no bullet on the object, then it will just return null. We want to get rid of the skeleton. So again, we have a special command for this. We can do destroy. Go ahead and give everyone a few minutes to get that up and written. I'll come back to code in a second. But now, we should be able to see that when we play that scene, the skeleton comes walking at us, but nothing's happening. No, why is that? The answer is because we actually didn't use a rigid body. So just like the bullet, the skeleton is going to need a rigid body to collide. So let's try and go ahead and do that. So we can add a rigid body. We can add a collider. And to demonstrate a point, I'm going to go ahead and do a capsule collider. Also, we can visualize the collider with this little button here that we can right, so the collider spawned at its peak, which we don't really want. We want that to be in the middle of the body. So we can go ahead and edit the collider over here by we're going to go ahead and move the center. Right, like that. And we're going to want to stretch it out on the other nice thing is that colliders, don't need to be perfect in the game world. They're just approximate. Because if we wanted to make the collision actually the plane of the skeleton, that would be incredibly computationally expensive. So instead, we can just do something that's good enough. So in this case, this will be, close enough that people won't really notice it. So I'll go ahead and save. Click play. Let's look around. Where's our skeleton friend? Oh no! He has rolled over. He is now simply frolicking on the ground. So if I go ahead and switch over to the scene view, you can see, yeah, the capsule collider wasn't very stable, and he just immediately plopped over and is now running aimlessly into the ground. That's not very good. So let's see if we can edit our collider here on rigid body in order to do that. And so we can actually use these constraints here. So there's two kinds of constraints. We have freeze position and freeze rotation, which do what they might sound like. So let's see which rotation of the skeleton we want to freeze, right? So we want him to be able to turn from left to right like this. And if we look at our rotation in our transform, you can see that's the Y rotation. So we want him to be able to turn to face the player. But that's the only rotation we want him to be able to do, right? We don't want him to be able to flop sideways or forwards, which are X and Z rotations. So I'm going to go ahead and click freeze rotation on the X and freeze rotation on the Z. Yeah. Why did that happen in the first place? Because it's a capsule collider. Imagine you took like a medicine pill, right, and placed it down. It's not going to stay upright. It's going to fall over. So, behave like that.
You're so smart, Professor.
Thank you. So now you can see, oh, he's wandering aimlessly into a wall. I'm going to be honest, I don't know why that's happening, but he has not fallen over. No, seriously, why is that happening? Oh, I think he just like walked through us. That's why. Anyway, let me just reset this to 0. All right. Cool. So now we should have a skeleton that looks towards us and walks towards us and does not fall over. I'll give everyone a few minutes, and I'll go ahead and pull the code up as well as everything we set on the skeleton enemy. If anyone has any questions or needs help with anything, feel free to raise your hand. All right, I'm going to have to double time it a little because we are like technically already at time and there's still some more stuff to do. So again, if you ever get stuck, just raise your hand and we'll have someone come help you out. There's a couple of things that we want to do. First off, we're going to want to make it, right? So right now the bullets live forever, which is still a problem because they can still clog up, right? They can still clog up all our memory by, existing forever, which is not something that we really want. So in order to alleviate that, we're going to go ahead and use time to check if the bullet should despawn. So if we go ahead and go back to our bullet script, we can set a parameter for how long we want the bullet to live. So public float, time alive, let's say 3 seconds. And then we're going to set a private float for when it would spawn. Cool. And then we're going to do something similar what we did to the fire rate, where we're going to save time when it spawns in. We're going to check if it too long has elapsed, and if so, we're going to destroy the object. So in our start function, we're going to put spawn time equals time.time. And then in our update function, we can set if the difference, so if time.time minus spawn time is greater than time alive. And so now if I fire off some bullets, you'll see they'll show up in my hierarchy. And then after 3 seconds, they're going to go ahead and despawn. Because that's what we made the bullet script to do. Awesome. Right? Cool. All right. Is there anyone who is not at that point yet? Let me pull up the bullet code again. All right. Cool. So currently, we only have one enemy, which is pretty lame. We kill a skeleton, and that's it. So what we're going to do is we're going to go ahead and make an enemy manager that can spawn in lots of different enemies. So we're going to go ahead and make a new game object. And for this, I'm just going to make an empty, right? Because all we want this to be able to do is to hold the script. We don't actually care about this being a physical representation of some object. So I'm going to go ahead and call this enemy spawner. And we're going to go ahead and make a new script for it as well. And then we're going to drag that onto our component and open it. All right. So, what are some things that we might want to be able to control on the enemy spawner? So we're going to want a reference to the enemy itself. So we can do that with a prefab again, public game object, enemy prefab. Control S. We might also want to be able to set the min and max distance. So public floats min dist equals, let's say, 5. Public float max dist equals 10. Public float spawn rate equals 1f. Private float last spawn next spawn time. All right. And I'm going to go ahead and use next time here just to show you that there's a couple different approaches that you can always take to the same thing. So instead of logging the last time we spawned and checking if it's been greater, instead we're going to calculate the time of the next spawn time and see if enough time has elapsed. So in our start function here, we're going to want to be able to spawn right away. So we can type next spawn time equals time.time. All right. And then in our update function, if time.time is greater than next time, next time is current time, spawn time plus equals spawn rate, and we can go ahead and instantiate a prefab. Cool. But we have a problem with our enemy spawner here, which is that if we instantiate things just at the position of this management object, we're going to have everything spawning in the center of the world, which is not what we want. We kind of want things to spawn far away and walk towards us. So in order to do that, I'm going to go ahead and write a function to randomly spawn some positions far away on the world. So we're going to write a new function here called random position. So private vector 3 random pause. All right. So in order to do this, we're going to spawn in a random angle from 0 to 120. And then we're going to go ahead and do our distance. For time's sake, I'm just going to set this to max distance. And then return new vector 3. Max dist times. Actually, let's go ahead and do this. Vector 3 dot forward. Times vector 3 dot. Why is that not happening? Unity engine dot random vector 3 dot forward. Why is that not working? I guess they've updated C# in a while. I'm going to go ahead and take off this system.numerics. I don't know why that is imported. Okay. Cool. All right, and so now we have an enemy script, an enemy spawner script, and there's two important things to do. Notice something important to mention is that we've been making our edits to the skeleton prefab, like the collider and the script, in the scene. If you make edits to a prefab in the scene, they aren't automatically saved onto that prefab. But there is a way we can do that using something called overrides. So we have a little drop down here on the top right in the inspector called overrides. If we go ahead and click apply all, then our changes are going to be applied to the prefab. So if you're ever making changes to a prefab, make sure you're either doing it with the prefab itself open, or if you do it in the scene, you can go ahead and click overrides, apply all to apply your changes to the prefab. You can drag that into the enemy spawner on the enemy prefab, just like that. I'll go ahead and disable this guy for now. Awesome. Where are the skeletons? Oh, it's because they're disabled. That's the important thing. Okay, so something else to note, right? So I disabled the skeleton enemy in the scene, and then even though the prefab itself, right, this guy is still enabled, be very careful about what references you're dragging in. So this skeleton enemy is referencing this specific one in the scene, but we don't want that. We want to reference the prefab that we've created. So just make sure that we go ahead and go into assets and select skeleton enemy, or you can drag it from the prefabs view over here, right? So now even though I disabled the one we had sitting around in the scene, we're still getting a nice wave of skeletons. Wowee. Awesome. Cool. I'm also going to go ahead and raise that max distance. That seems pretty close. 10 is pretty close, so I'll go ahead and set it to 15. All right. But all the skeletons are coming at us from the same place, which is kind of boring. So we can do some math that I realize we probably should have predefined for you. Sorry about not doing that, but it's not that bad. In this random pause function here, instead of doing this, we can go ahead and do distance. We can define our vector 3. Instead of just multiplying the forward direction, we can go ahead and do return new vector 3 math dot cosine of angle. I spelled angle wrong. That's cool. Cosine of angle times times distance. Y of 0. Nope. Times distance. Y of 0. And again here, math dot sine of angle times distance. And then right here it's complaining about it being a double, so we'll go ahead and convert that to a float with some casting. All right. I know it was quite a bit, so yep. You're going to need to be using system. So when I type math, it auto-imported, but it might not auto-import for you. So make sure you have using system in your imports list. Yeah, if it didn't auto-import. All right. Cool. So now if we go ahead and hit play, look around, something is still up. I might have written my code wrong. Okay. Here's the problem. You can see we're not actually spawning the skeletons at the random position. So in our instantiate call here, we want to make a call of that function in order to pass that as the position that we use when spawning the skeletons. All right. Now if I look around, there we go. Now we've got some skeletons. All right. You can see our bullets still aren't killing them. Instead, they're just kind of making them wander around aimlessly. So we can go ahead and edit that. On our enemy script, why is that not working? That should be working. All right, welcome to the other part of Unity, which is called debugging. Sometimes your code does not work how it should for no particular reason. So I'm just going to check our bullet class here is correct. We have on collision enter written correctly. Collision.game object, that get component bullet is not null, destroy game object. I could have forgotten to put the bullet script on our bullet component. Let me check here. Nope, I did not. Is it giving me any errors? Nope. All right, live debugging. I'm just going to kill these mouse input prints. syntax exception. That's why. The ground. Okay, so it has nothing to do with my code and everything to do with the code that is written in the enemy script. Very cool. Let me despawn this guy. Cool. So now we arrive to the fun part. I have literally no idea what this error is. This is something from the imported package that worked when I tested this last night. Haha. Good component mesh collider dot shared mesh. What? Why do we use this? All right, live debugging. Does this have a mesh collider? Shared mesh. When in doubt, I'm gonna try commenting this all out and seeing if that works. If not, then I give up. Alright. That worked. Yay. But the skeletons are still not getting destroyed when they are getting hit by bullets. In fact, it seems like the collision isn't registering at all. Let's see if we can figure out why. The sphere has a bullet component. It has a rigid body. Okay, it seems like the collision is just not registering at all, which is awesome and amazing and very cool and definitely not incredibly irritating. Did I spell this wrong? On code. Agent. There we go. Okay, it seems like the collider was just stuck in the ground. Yeah, there we go. All right, so if you want to fix it, go on your enemy script. I think what was happening was that the bottom of the capsule collider was spawning in the ground, and it didn't like that. So just set the Y on the collider, or the center Y, to 1.01, and that will fix it. So I can go ahead and clear all this out. Cool. And now we almost have a full game. There's just one last problem we need to solve, which is that we can't die. So if I shoot bullets at skeletons, the skeletons will die, the bullets will despawn. Right? But if the skeleton comes and hits us, nothing happens. So we want to make it so that we die when the skeleton hits us. So in order to do that, we're going to go ahead and go back to the player script. And once again, we're going to use our friend onCollisionEnter to test when something hits the player. Actually, we're going to use something a little different. We're going to use a method called onTriggerEnter. So triggers are just like collisions, except triggers are volumes. So collisions have things, right? So if you have, for example, like two balls, right, and they hit each other, right, that's a collision. There's two things happening. My hand hits a desk, a ball hits another ball, foot hits a soccer ball. Those are all collisions. But sometimes you want to check when things have passed through a volume but not collide. So for example, in Mario Kart, you want to check when you drive past the start line, right? But we don't want you to run into the air where the start line is. We just want to be able to check if you've passed that in order to count your next lap. So you can set colliders to be triggers where they just check if things are inside of their area without actually running into them, right? So if this desk was a trigger, I could walk right through it but still know when I was hitting it. So that's what we're going to do for the player as well. So I'm going to put onTriggerEnter, collider, other. And then we're going to do the same kind of logic we did with bullets. So we're going to try and see if this is an enemy. So enemy equals other dot object dot get return of enemy. And then we're going to check if it's not null. And so we want to die. And so what do we want to do? We're going to do the simplest thing we can possibly do, which is restart the game. If you get hit, the game's over and we restart. So in order to do that in Unity, we have scene management, what we call scene management. So we can get the current scene with scene s equals scene manager dot get active scene. And then we can do scene manager dot load scene s. So what this will do is when the trigger volume is entered, I have to do s.name because scene manager works based off the names of strings, not scenes themselves. So now what's going to happen is if something walks into the player's trigger area, then it's going to go ahead and reset the scene. But of course, there's one last thing, which is that the player doesn't have a trigger area. So we can go ahead and go onto our main camera here, and then add a capsule collider again, and a rigid body. We're going to set the player rigid body to is kinematic, and this means that it won't move around. Dcheck use gravity as well. And then we're going to, on the collider, make it into a trigger. Go ahead and save. Cool. And now we have it set up that if we get hit by the skeleton, the scene will reset. So now I can play the game. Oh. They're a little far away. Oh, there we go. Hello, skeletons. All right. And that does it. So that is all of the code that you need to make your first fully functioning game. Of course, there's still lots more things you could do. As you could see, it was kind of unfair. So if we wanted to, we could go to our enemy spawner and make it so the skeletons spawn farther away. So we could set it to 15, for example, or we could increase the spawn rate such that it takes longer time. We could make the player move around. All sorts of different stuff we can do. But I hope you guys enjoyed and learned the basics. Thank you guys so much for coming out. If you have any questions as you're finishing up, feel free to let us know. And this VOD will all be posted on Twitch for you guys to reference in the future as well.
Thank you, Chase.